We now write the Maclaurin polynomial of degree 3 for the function f of x equals e raised to the power of 4x. And so this is the formula to find the Maclaurin polynomial of degree 3. That is t3 of x equals f of 0 plus f prime of 0 times x divided by 1 factorial plus f double prime of 0 times x squared divided by 2 factorial plus f triple prime of 0 times x cube divided by 3 factorial. So let's find each terms in this series one by one. First, we have to find f of 0. So first, let me write this function f of x, and this equals e raised to the power of 4x. So this implies we can find f of 0 by replacing x by 0 in this expression. So this becomes e raised to the power of 4 times of 0, and this equals e raised to the power of 0, and this equals 1. So f of 0 equals 1. Now let's find the first derivative of f prime f of x, that is f prime of x. And this equals, we have to find the derivative of e power 4x. So derivative of e power 4x is e power 4x. And then when you apply the chain rule to find the derivative of 4x, we get this 4. So it is 4 times e raised to the power of 4x. And this is the derivative of f of x, that is f prime of x. Now using this, we can find f prime of 0 by plugging in x equal to 0 into this f prime of x. So therefore this becomes 4 times e raised to the power of 4 times of 0, and this equals 4 times of e raised to the power of 0 is 1. So 4 times of 1 equals 4. So f prime of 0 equals 4. Now let's find the second derivative of f of x. So we find the derivative of this f prime of x, that is f double prime of x, which is the second derivative of f of x, and this equals, this is the expression that we use. So we have a constant here, we put this constant, and then find the derivative of e power 4x, which is e raised to the power of 4x. And once again, we have to do the chain rule to find the derivative of 4x, which is 4. And so this gives us 4 times 4 is 16 e raised to the power of 4x. And so using this, we can find f double prime of 0 by plugging in x equal to 0 into this expression. And so when we do that, we get 16 times of e raised to the power of 4 times of 0. And this is e raised to the power of 0, which equals 1. So 16 times 1 equals 16. So we get f double prime of 0 equals 16. Now let's find the third derivative. So I do f prime of triple prime of x, and this equals, this is the expression I use. I put this constant 16, find the derivative of e power 4x, which is e power 4x. And once again, apply the chain rule to find the derivative of 4x. So we get 4. And so this equals 16 times 4 is 64 e raised to the power of 4x. And so we can find the f triple prime of 0, and this gives 64 times e raised to the power of 4 times of 0, and this equals 64 times e power 0 is 1, so it is 64. So we found the f triple prime of 0 equals 64. Okay, so now we have found all the values which are required to substitute into the formula, which we'll do now. So I write the Maclaurin polynomial, that is t3 of x, and this equals, the first one is f of 0. F of 0 is 1 plus f prime of 0 times x divided by 1 factorial. F prime of 0 is 4. So I put 4 times of x divided by 1 factorial, and then in the formula we have f double prime of 0, which is 16. So I put 16 times of x squared divided by 2 factorial, and then we have f triple prime of 0, that is 64 times x cube divided by 3 factorial. So let's simplify this, and so this gives t3 of x, and this equals 1 plus 4 times x is 4x, and divided by 1 factorial is 1, so it is 4x. And here we have 16x squared divided by 2 factorial is 2 plus 64 times x cube, which is 64x cube, and divided by 3 factorial is 1 times 2 times 3. So we can simplify this. This goes 32 times. So it's basically 32x cubed by 3. And here also I can simplify this. This is 8 times. So therefore this implies t3 of x. And this gives 1 plus 4x plus 8x squared plus this is 32 by 3 x cubed. And so this is the Taylor polynomial of degree 3 for the function f of x equals e power 4x. Now using this we approximate the value of e power 12. So we have to plug in x equal to 12 into the Taylor Maclaurin polynomial expression, that is e raised to the power of 12, and so this is approximately equal to 1 plus 4 times of 12 replace x by 12 plus 8 times of replace x squared by 12, so it becomes 12 squared plus 32 by 3 replace x by 12, so it becomes 12 cube. Now let's simplify this. So e power 12 approximately equal to 1 plus 4 times 12 is 48, and this is 12 square is 144, and then 144 times 8, and this equals 1152, and we can plug this into the calculator. That is 12 cube times 32 divided by 3, and this is 18,432. And so we just add these four numbers: 1 plus 48 plus 1152 plus 18,432. And when we add this, we get approximately 19,633. I'm sorry. So this is the approximate value of e raised to the power of 12. I'm sorry. I just figured out that we have to replace x by 3 instead of 12. So this answer, we may have to relook into this. It's not correct. So let me just remove this, because we are finding e power 12, and this means 4x equals 12. So therefore x equal to 3. So we have to replace x by 3. So let me do that. So this has to be replaced by 3. And so I'll just erase these numbers. And so this is 4 times 3 is 12. And this is 8 times 3 square is 9. So it is 72 plus we have 32 by 3. 3 cube is 27. So we can cancel this 9 times. And so we add these numbers 1 plus 12 plus 72 plus 32 times 9. And this equals 288. And so when we add these four numbers, approximately 373. And so this is the approximate value of e power 12 using this polynomial.